Hello everyone, today we're going to discuss kinetic energy. By the end of this video you'll be able to solve problems using kinetic energy, and it will lay the groundwork for the rest of energy as it relates to physics. So what is kinetic energy? So the kinetic energy is basically the energy associated with how much an object is moving. So if we have an object and it has some velocity, it's going to possess some kinetic energy, and we call this translational kinetic energy, as it's moving in like a straight line. So that's where this velocity comes in. So it's also important to note that the energy is a scalar quantity, so it does not have a direction. And we can figure out what the units are. So if we if we have our kilograms for our mass and our velocity is meters per second, and we square this, the units for energy are kilograms meters squared per second squared. But you won't hear people saying, I have this amount of kilograms meters squared per second squared, so we define this as a joule. And so a joule is a unit of energy that you'll commonly see. Alright, so let's do an example. So we have a 7 kilogram ball is thrown downwards 5 meters per second and has a velocity of 10 meters per second when it reaches the ground. What is initial, final, and change in kinetic energy? So let's list out what we have here. So we have the mass of the ball, which is 7 kilograms. We have the velocity initial, which is 5 meters per second. And this is downwards, but you'll see this negative sign won't matter when you plug it into the equation. And the final velocity is 10 meters per second, which is also downwards because the ball is falling downwards. So if we want to find our initial kinetic energy, we know it's 1/2 mv squared. And if we just plug in our values here, we have the mass of 7, this initial velocity, which is -5, but since we're squaring it, this negative will cancel itself out, and so we'll get 87.5 joules. And so our final kinetic energy is going to be plugging in our mass, which is not changing, and the velocity final, which is a -10 squared. So if we plug that in, we get 350 joules. And so now to find the change in kinetic energy, we can simply do the K final minus the kinetic energy initial, which is 350 minus 87.5, which equals 262.5 joules. So something to note is that the kinetic energy itself will never be negative, but the change in kinetic energy could be negative. So we'll learn in the next video about work, and then later how this change in kinetic energy relates to the work. So make sure you stay tuned for that, and thanks for watching.